Math 3, Unit 1, Section 1. Today we're talking about parent graphs. So most of what we're talking about today should be a review, but some of you might not remember it, so that's why we're going through it. One resource that I want you guys to remember is Desmos.com. So as you're doing your homework, if you want to check to make sure you actually did it correctly, it's a great idea to go there, plug the equation in, and just double check your work. Okay? So linear equations. Linear means it is a what? A line. Very good. Okay, and this basically is your definition of a line. When we are talking about it this week, you're going to see it in this form too. Y equals m, and then x plus 0 plus 0. So what happens is this 0 and this 0 kind of gives you your starting point on the graph, and then you can use your slope to make your line. For right now, we're going to just plug in values. Some of you probably know how to graph this maybe without plugging in values, but we're just going to practice that. So you can choose any points to plug in. I'm going to choose an x value of 0. And so in this equation right here, when you plug in 0, you get 2/3 times 0, which actually equals what? Good. And so that point is at 0, 0. So we're going to plot it, point at 0, 0. Do you guys remember how the coordinate plane works? So going to the right is positive, going to the left is negative, up is positive, down is negative. Okay, 0, 0 is in the middle. Okay, next, now we can choose any value. Some people just want to choose 1. I don't think 1 is a great value to choose because I'm left with a fraction, right? Because 2/3 times 1 would be 2/3. So what would be a good value to choose? 3, good. And so when you choose, we have 2/3 times 3, and you could even write that as 3/1. What happens to those 3's? They eliminate, right? They cancel out, cross reduce. And so what do you end up with as your answer there? 2. And so the next order pair we have is 3, 2. So on our graph, we're going to go right 3 and then up 2. And also you guys remember with points that they go the x value, then the y value. This is your x-axis. This is your y-axis. Yes? Okay. So we chose a positive value. What would be a good negative value to choose? Very good, -3. And so 2/3 times -3. Again, the 3's will end up reducing. And what answer would you end up with? -2. And so we end up with -3, -2. So the -3, we go left 3, down 2, and then you can draw your line. Remember with lines, when something is going in both directions, you want to have those arrows. That's letting you know it's a line. You know the difference between a segment and a line. Segments don't have the arrows, so on all these you should have arrows at each end. Any questions here so far? Okay, so we're going to go ahead and move down here, and we're going to do this next line. Since we're plugging in points, this doesn't have to be y equals, but I would recommend getting the y by itself because it makes simplifying and everything a lot quicker, easier. Okay, so what would I do to get y by itself here? Good. Subtract 3x to both sides. Bless you. So that eliminates that there. On the left side now, I'm just left with y equals -3x, and you could put plus 0, but you don't need to. So again, we're going to choose 2 points. I'm going to choose 0. -3 times 0 equals 0. So this point is at 0, 0. The next one, what should we choose? Yeah, we could choose -1. There's no fractions here, so choosing a small number is good. -3 times -1 equals +3. Good. So negative 1, 3. We're going to plot that. We go left 1, and then up 3. And then we want to choose a positive value, so we can choose positive 1. Negative 3 times 1 equals negative 3, and so my ordered pair is 1, negative 3. And then draw your line. When you're reading graphs, you read them from left to right. And so if you know here, starting at the left side, notice how the line is going down. And so that's a way of double checking. This is a negative slope, and this is making a negative line, so you know you didn't make any mistakes. Okay, any questions on this one? Am I going too fast? Okay. What would I do to get y by itself on this one? Good, divide by 2. So the 2's eliminate. I'm going to flip this equation around and put the y on the left side. So we get y equals, this is going to be 5 over 2x. So what's the first value I should choose? 0, good. And we know that 5 over 2 times 0 equals 0. Okay, what would be the next value that would be good to choose? 2, good. So 5 over 2 times 2, or 2 over 1. The 2's end up reducing, and what answer do we get? 5, good. If this isn't making sense to you, just to make sure, with fractions, you multiply tops with tops, bottoms with bottoms, or numerators and denominators. 5 times 2 is 10, and then 2 times 1 is 2, but 10 over 2 reduces to be 5. Remember, the shortcut is that you can reduce anything on the top with anything on the bottom. And so since there were 2 2's, I could have skipped that step, which is what I was doing before, reducing the 2's and ending up with 5 over 1, which is the same thing as 5. As I am doing notes, if you guys have questions or you're like, that doesn't make sense, just stop me and we will go over it, okay? All right, so write 2 at 5, and then another value would be to choose what? Good, negative 2. So 5 over 2 times negative 2, and we can write negative 2 over 1. Again, anything on the top can reduce with anything on the bottom, so these 2's can end up reducing, and we end up with 5 times negative 1, which makes, good, negative 5, and so we have negative 2, negative 5. So left 2 and down 5, and draw our line. Okay, questions? All right. Next, we're going to talk about quadratic functions. And what are quadratic functions? What's another name for those? Good, parabolas. They make the U-shaped graph. Okay, this is our standard equation. Another way we look at this one is in vertex form, which is y equals a parenthesis x plus 0 squared plus 0. The value here in the parenthesis, this right here, is telling me the x value of the equation. And this is the y value. And if you notice, we had a point here at 0, 0. Again, here, the x value of the equation and the y value. So a starting point would end up being 0, 0. And this is going to be helpful as we move on through the unit. The other thing you want to remember is that the x value that's here in the parentheses, you would always end up setting this to 0, and so it ends up becoming the opposite value. But there's no opposite value of 0, so it's just 0. And again, we'll talk more later. But I just want you to see this as we move on. So y equals x squared, we're going to plug in values again. If I plug in 0, what is 0 squared? 0. So that point is at 0, 0. Okay, what would be another value we could plug in for this one? 2. Good. Could we have chosen 1? Yeah. Could we choose 3? Yes. So we're just choosing values. We don't all have to choose the same. I like 2 though because it spreads it out a little more. 2 squared is 4. So my next point is 2, 4. And then another value we would want to choose is what?
3.
We can choose 3, but it's good to always choose a positive and then also a negative so we can see what's happening on both sides of that y-axis. Okay, so I'm going to go ahead and choose -2. And -2, when you square it, actually becomes what? +4, because a negative and a negative make a positive. So we have the point -2, 4. So left 2, up 1, 2, 3, 4, and we have our curve. If you didn't get something that looked like this, you'd want to go back and check your math to make sure you didn't do something wrong. Okay, questions there? All right, we're going to move down then. So in this one, again, y is already by itself. We're going to plug in 0. -3 times 0 squared is going to give me what? 0, because 0 squared is 0. -3 times 0, 0. The point is 0, 0. Okay. Next, we're going to plug in what value? We could do 1, but it might make this, or I mean 2, but it's going to end up making this bigger. So I'm going to stick with 1 so my numbers stay smaller. So 1 squared is what? 1. So remember, order of operations, you have to do exponents first. And so 1 squared is 1, and then -3 times 1 is -3. So the order pair is 1, -3. And then we'll plug in -1. So -3 times -1 squared. And again, what is -1 squared? It ends up being +1, correct? And -3 times +1 makes a -3. So -1, -3. What do you notice about this graph? It's going down. And so if you'll notice, when you have a negative in front like that, the curve should be going down. Okay, last one here. We'll go ahead and plug in 0 again. 2 times 0 squared is 0. So we have a point that's 0, 0. We'll plug in 1. 2 times 1 squared. Very good. So 1 squared is 1. 2 times 1 is 2. So we have a point 1, 2. And then -1. 2 times -1 squared. Very good. Also becomes 2. -1 squared is +1, and -2 times 1 is, or sorry, 2 times 1 is 2. So I'm going to go ahead and plot those points. So we have 0, 0, 1, 2, and then -1, 2. All right. Any questions on the quadratics so far? Okay. Linear absolute value. Do you guys remember what absolute value graphs look like? Very good. They make a V-shaped graph. Do you know why they make a V-shaped graph? Okay, so first of all, linear absolute value, it's actually a line. But when you take the absolute value of something, what does it end up making it? Very good. It changes a negative to a positive, or a positive stays positive. So what ends up happening is the negative values end up becoming positive, which ends up flipping it up on the graph. So it was a line, but any negative values flip up and make it positive, which is how it makes a V. Okay? So, again, this one, just like before, how I was kind of talking about these other graphs, this could also be written for a parent graph is y equals a absolute value of x plus 0 plus 0. Okay, so these are basically our parent graphs right here. This helps us with translating and shifting it later on when it's not 0, 0. Okay, when I plug in 0 into this equation, 2/3 times the absolute value of 0. Well, what's the absolute value of 0? 0, good. So we end up with 2/3 times 0, and my answer is 0. Okay, what would be a good value to choose on this one? Good, 3. And again, why am I choosing 3? Very good, eliminating the fractions. Okay, so 2/3 times the absolute value of 3 over 1. Well, what's the absolute value of 3 over 1, or absolute value of 3? 3. So I end up with 2/3 times 3 over 1. And that ends up reducing to become what? 2. Very good. Because again, my 3's can reduce. So my ordered pair is 3, 2. Next, I'm going to plug in -3. So we have 2/3 absolute value of -3. What is the absolute value of -3? +3. So I have 2/3 times +3, or 3 over 1. The 3's reduce, and we end up with what? 2 as well. So the ordered pair is -3, +2. And this one, make sure that when you draw it, you are drawing it as lines. Okay, so this one, it's curves and absolute value, they're lines. You are right. Good job. Also in my class, if you find math errors, you automatically get a candy. So that is a candy for you. Very good. All right, thank you. Okay, anything else on this one? All right, so let's move down. Let's practice another one. So we'll plug in 0. -3 absolute value of 0 is it's gonna be -3 times 0, which is 0. Good. So that point is 0, 0. What value do we want to choose next? 2? Okay. So -3 absolute value of 2. That ends up becoming -3 times 2, which is -6. So 2 -6. And then we need to choose a negative value, so I would suggest choosing, good, -2. -3 absolute value of -2 is -3 times 2, which ends up being -6. So -2, -6. And again, these should be lines. All right, last one. Plug in 0. Absolute value of 0 is 0. So 0, 0. What's the next value you want to choose? 1? Okay. Absolute value of 1 is 1. So we have 1, 1. And then we need to choose -1. What's the absolute value of -1? 1. And I wrote this as 0. I meant to write it as 1. You almost got another candy. Okay. 0, 0. And then right 1, down 1, and left 1, down 1. Okay, any questions? Do I need to make this bigger for some of you? Yes? No?
Why is it upside down?
You're right. Good job. So, right 1, up 1, left 1, up 1. It was a trick question. Okay. Do we all agree with this one now? Very nicely done. Okay. Anything else? Okay. All right. Exponential functions. Do you guys remember these? Very good. So it looks like it gets really close to a line and then it shoots up. It goes up very quickly. Exponential equations have something called a asymptote. And I feel like I might be spelling it wrong. So there you have it for now. If I spelled it wrong, I'm sorry. Okay. So we're going to plug in values. What value should we always start with? 0. Good. Okay, so 2 to the 0 power. Do you remember what happens anytime you have something to the 0 exponent? Very good. It becomes 1. There's a reason behind that. We're not going to get into it right now, but if you want me to tell you later, I'll show you. So we have the point 0, 1. So 0, up 1, not down 1, in case you were wondering. Oh my gosh. What is wrong with me today? I still made it right on here, though. Oh my goodness. I am very proud of you guys, though, and I'm helping you become better problem solvers right now, just so you know. Okay. There's a purpose. Okay, now, what other value should I choose? We could choose 3, but it's going to make, if you think about 3, 2 to the 3rd power is what? 8, and it's going to go off the graph. So let's not choose that. What should we choose? Okay, let's try 2. Okay, 2 to the 2nd power is 4, and so we have 2, 4. I should probably have somebody else come up here and do this, but we go right 2, up 1, 2, 3, 4. Okay, and then what would be the other value I should choose? -2? Okay, so 2 to the -2nd power. Who remembers how to do that? Fraction. Good job. So whenever you have a negative exponent, it ends up changing sides when you want to make it a positive. So I always think about, if I have 2 to the -2nd, it's over 1. And so you have to take this negative part and bring it to the denominator. And so you end up with 1 over 2 to the 2nd power, which ends up becoming what? 1 over 4. Good. So this ordered pair is -2, 1/4. So what does that mean when you're plotting it on a graph? Very good. It's in between 0 and 1. It's just a little bit above the line. So let's see if I can mark this right. So we're going to go -2 and up 1/4. So something like that. It just has to be in between 0 and 1. Are we good there? Okay. Do you think there is any value I could choose like that would end up making it get to 0, 0? So like if I chose, let's say, -100, 2 to the -100 power would just give me a really small fraction. Exactly. And so that is telling us that there's an asymptote here. So what that means is that the line will get really, really close to 0, but it never actually touches 0. And so we need to mark that asymptote. And so you do that with a dotted line. Okay? This dotted line right here, it is going through the point y equals 0. And so this is actually called y equals 0, this line. And then your asymptote, we draw our curve like that. Okay. Do you guys have any questions for me on this? Did I make any errors? Yes?
Why do you have to put that?
The asymptote? Okay, so all exponential functions will have an asymptote, and so we always want to label this so that we know this line will never touch there or go below. So it's kind of like letting us know that it's never going to cross, and then it's showing the graph. Does that kind of give you better? Okay. So this will sometimes shift. And today, all of them are going to be at y equals 0, but as the graphs move up and down and translate, this asymptote will also change. Okay? All right, so y equals 3 to the x power. We're going to start with what? 0, very good. 3 to the 0 equals 1. Anything to the 0 power is 1. So this point is at 0, 1. 0 up 1. Make our point. Okay, next we should choose, if we choose 2, 3 to the 2nd is 9, I'm going to be off the graph. So we're going to go ahead and choose 1. 3 to the 1st power is 3, good. So we have a point at 1, 3. So right 1, up 1, 2, 3. And then we'll go ahead and choose -1. 3 to the -1 power is going to give me what answer? 1/3 is correct. Good. So -1, 1/3. So -1 up 1/3. My asymptote is at what value? Good. Y equals 0. So that's an equation of a line. So make sure you're writing y equals 0. And then you can draw your exponential function. Questions? Okay, last one. Y equals 4 to the x. So we'll plug in 0. 4 to the 0 is 1. 0, 1 is our first point. We'll go ahead and plug in 1. 4 to the first is 4. And so we have 1, 4. So write 1 up, 1, 2, 3, 4. And then negative 1 is going to give me what? Very good, 1/4. So negative 1 and 1/4. Where's our asymptote? Very good, y equals 0. And there we go. Okay, we're going to go ahead and turn the page. We're going to do just the 3 more at the top, or 2, sorry, at the top, but they're special cases. So remember that horizontal lines are in the form y equals b, where b is a constant. And so here y equals 2. Remember, this is our y-axis and this is our x-axis. If I go to y equals 2, it's up 2, but your line goes horizontal through that point. If it went up and down, it'd be hitting every single y value. And going this way, it's only hitting our y equals 2. Okay, and over here, x equals negative 3. We would go on our x-axis here to negative 3. And that one is going to be vertical because it's only going to hit the value at negative 3. Any questions?